Welcome back. In part 2 of this lesson on sequences, we're going to now look at how we can actually represent both arithmetic and geometric sequences using formulas. So let's start off with looking at the arithmetic sequence formula. So this is a really handy tool that will help us out for finding out terms that are further on down the line. So let me help you read this formula out. So this simply means just the arithmetic sequence of whatever term. So n represents whatever number term, the nth term we'll call it. So term is just the position of the number in the sequence, like the first term, the second term, the third term, fourth term, and so forth. S represents our starting term, our initial value, and then D represents our common difference. So let's use this information down below to help us out with understanding how this formula works. So let's consider the following sequence. So we've got these four numbers. So let's identify what the starting term is. Well, pretty obvious right there. First number in our list, which is 7, right there. Okay, and then let's figure out what is our common difference. So it looks like our common difference for this problem is positive 6. So let's use this information to write a formula representing the arithmetic sequence. So if we use this as our format up above, so a of n, or we read this as a subscript n or a sub n. So a sub n equals, looks like, so we're going to start off with our starting term, which is 7. So we got 7 plus, and we're going to write n minus 1 times our common difference, which is 6. So there's our formula that represents the arithmetic sequence for this example. So now we're going to use this formula to find the 12th term in this sequence. So we're going to plug 12 in for n. So the arithmetic sequence for the 12th term is going to equal as follows. So it's going to be 7 plus parentheses. So for n, we're going to replace that with 12 times 6. So we're going to use order of operations to work this problem out. So let's do the parentheses first. So that's what we end up with. Then we multiply, so that's 66. And then we add these numbers together, and that gives us 83. So the 12th term in this arithmetic sequence will go out to the value 83. So the great thing about this formula is that we can use it to find any term in the sequence. The 100th term, the 250th term, the 1000th term, and so on and so forth. So that's a beautiful thing about using the arithmetic sequence formula, is that we can find the position for any term in any number pattern, just as long as we know the starting number and the common difference. Let's try a set of quick check problems out. So for these two problems, what we're going to do is find the 50th term for each of the following arithmetic sequences. So you'll notice I haven't written out the number pattern, but I have given you the starting number and the common difference for each one of these problems. Take a moment to figure out how you would write the formula out for each one of these problems. You can pause the video right here and set up your formulas, and then you can hit play once you're done setting up your formula. All right, so if you've set your formulas up correctly, this is what you should have for the following problems. So for the first one, a subscript n equals 14 plus n minus 1 in parentheses times negative 3. And then for problem number 2, we have a subscript n equals 77 plus n minus 1 in parentheses times 11. So what we're going to do, we're going to find the 50th term for each of the following arithmetic sequences. So for the first one, so we're going to calculate for the 50th term. That equals 14 plus 50 minus 1 times negative 3. So order of operations, so that's 49 times negative 3. Don't forget the plus 14 out in front. Then we multiply 49 times negative 3. 49 times negative 3 gives us negative 147. And don't forget, we're going to add that with positive 14 off to the side. So 14 plus negative 147 equals a grand total of negative 133. So there is our 50th term for the sequence. Pause the video right here and try out the next problem on your own. And when you're done, hit play and compare your work. All right, if you set it up correctly, this is what the first line should look like. So after you take care of the parentheses, you get this statement, so 77 plus 49 times 11. Then you multiply, and you get that. Then you add your numbers together, and you get a total of 616. So the 50th term of problem number 2 would be the number 616. Let's take a look at the geometric sequence formula now. So the formula for geometric sequences is slightly different, as you can tell. We still have some common variables like in the arithmetic formula. So n represents the number term that we're on, so first term, second term, third term, and so forth. S is our starting term, and then R represents our common ratio. Now what makes this formula very unique, because of the nature of geometric sequences, it actually turns out to be more of an exponent operation that takes place. So let's take a look at the example down below. We've got this geometric sequence that I've worked out for you, and we see that it continues on forever. So let's identify some things. So let's first identify the starting term. So that's the first number here, which is 4. And then we got to figure out the common ratio. So remember, it's second term divided by the first term. So 12 fourths, or 12 divided by 4. 12 divided by 4, which gives us 3. So there is our common ratio. Let me fix that. There we go. All right, so now we're going to use this information to write a formula representing the geometric sequence. So let's fill in what we know. So G subscript n equals the starting number, which is 4, times common ratio, which is, in this case, 3, and then in parentheses, n minus 1. Now, some textbooks may not have the parentheses around this exponent. It's fine, not a big deal. If you put parentheses or not, it doesn't have any effect on the calculation. So now, let's use this formula to find the 20th term in the sequence. So we're going to calculate the 20th term. So let's use this information. So 4 times 3, and then in the exponent we have 20 minus 1. So if we were to simplify this down, it's the same thing as 4 times 3, and 20 minus 1 is 19. So we're really multiplying 4 times 3 to the 19th power. So as you know, using a calculator is going to be very helpful for us in this situation. All right, let's plug in what we know. So let me clear that stuff out. All right, so we've got 4 times 3. And if you remember, on most calculators, the exponent button looks like this right here. So we click that and then type in 19. And then when we multiply that out, we see that we end up with a really large number. And that makes sense too. So let's write that out. So we got 464, 904, 5868. Really big number. So if we were properly formatting this, remember we group by threes going from right to left. So we end up with a number that looks like this. So 4,649,045,868. There you go. Let's try some quick check problems out. So for these two problems, we're going to find the 30th term of each of the following geometric sequences. So I've given you the starting number and the common ratio for these two problems. You can pause the video right here and write out the geometric sequence formulas and then hit play so that you can compare your work to see if you're on the right track. So if you've set your formulas up correctly, this is what the format should look like for both problems 1 and problem 2. So remember, 8 is our starting number, and then 1/2 is our common ratio for problem number 1. And then for number 2, 10 was our starting number, and then 2 was our common ratio. So now what we're going to do is calculate the 30th term for both of these problems. And we simply do that by plugging in 30 into the variable n. Now if we were to simplify this down, it's the same thing as saying 8 times 1/2, and then 30 minus 1 is 29. So you can use your calculator and work that problem out. And if you've done the problem correctly, you end up getting a number that is really, really small. It looks like this, 0.000. Let's see how many zeros there are. 1, 2, 3, 4, 5, 6, 7, and then 1, 5. So we would read that number as 15 billionths. Very small number. Pause the video right here and see if you can set up this next problem on your own, and then hit play to see how it matches up with my work. So if you've set the problem up correctly, this is what your work should look like. So the 30th term would equal 10 times 2 raised to the 30 minus 1 power. Or if you simplify that down, that's the same thing as 10 times 2 to the 29th power, which works out to this value. 5,368,709,120. So very important to remember, class, that whenever you're working with either formula, arithmetic or geometric sequences, make sure you are being careful plugging in your numbers into the correct variables, and then of course making sure that you are very careful making your calculations. The biggest problem is a lot of times user error, and a lot of times careless mistakes can happen when plugging numbers into a calculator. So just be very careful whenever you're doing these types of problems. Hope you found these examples helpful. Let me know if you have any questions. Thank you.